Something just shifted in the atmosphere, and it happened days before anyone thought it would. The computer models that guide every forecast in this country went to sleep one night, showing a hot, stubborn, unmoving late summer, and they woke up showing something completely different. A pattern is now locking into place across the top of the world, a pattern so large it stretches from the coast of Alaska all the way to the frozen edge of Greenland, and it is going to reach down and grab the middle of the United States by the collar. If you have been sweating through night after night that never cools off, if you have been staring at your thermostat wondering when this endless heat finally breaks, the answer is closer than most coverage has suggested, and it is arriving faster than almost anyone expected just a week ago. Start with the part that matters most, and then work backward into the machinery behind it, because the how is every bit as fascinating as the what. Up near the very top of this hemisphere, high in the atmosphere where the jet stream races around the globe like a river of wind, something called a blocking pattern is forming. The word blocking is exactly what it sounds like. Normally, the jet stream flows fast and mostly straight from west to east, dragging weather systems along with it one after another, keeping everything moving. But every so often, a giant dome of high pressure plants itself in one spot and simply refuses to budge. It behaves like a boulder dropped into that river of wind. The flow can no longer pass straight through, so it bends. It buckles. It carves out enormous loops, and inside those loops, cold air that normally stays trapped up in the Arctic suddenly finds an open door leading south. 2 of these boulders are setting up at once right now, and that is precisely what makes the current setup so unusual. Forecasters watch a handful of key measurements to know when this kind of shift is about to happen, and right now, several of them are flashing the same signal simultaneously. The first is called the North Atlantic Oscillation, essentially a way of measuring the pressure pattern set up over the northern Atlantic near Greenland. When that number swings negative, it means high pressure is building over Greenland, one of the 2 boulders already mentioned. The latest data shows that number diving negative within the past several days and staying there with current guidance suggesting it holds through the final days of August and potentially into the opening days of September. That is not a small blip. That is a sustained shift, and it is exactly the kind of setup that reroutes cold air toward the eastern half of the country. The second measurement is the East Pacific Oscillation, which governs what happens up near Alaska. When it goes negative, a ridge of high pressure balloons up over Alaska and the northeastern Pacific. That is the second boulder, and here is the part that made forecasters look twice at their screens this week. Both of these signals are turning negative at nearly the same time in the same window, and they reinforce each other directly. A negative reading near Alaska builds a block on the western side of the continent. A negative reading near Greenland builds a block on the eastern side. Put a wall of high pressure on both ends, and the cold air trapped in the middle of that buckled jet stream has nowhere left to go but down, straight into the heart of North America. Understanding why blocking patterns are so much harder to forecast with precision than ordinary day-to-day weather also helps explain why this particular disagreement between models carries so much weight. Most everyday forecasting relies on tracking discrete weather systems, individual fronts, individual areas of low pressure, moving along a relatively predictable conveyor belt shaped by the underlying jet stream. Blocking patterns break that conveyor belt entirely. Once a block establishes itself, the atmosphere essentially gets stuck in a holding pattern, and small differences in exactly how strong that block becomes, or exactly where its center sits, can produce dramatically different outcomes downstream. Sometimes the difference between a mild cool down and a genuinely historic late summer cold outbreak. That sensitivity to small initial differences is precisely why 2 extremely sophisticated forecast models, both built by serious scientific institutions and both fed the same underlying atmospheric data, can nonetheless diverge this much on the details, even while agreeing completely on the broad strokes. Now, an honest disagreement is playing out between the models right now, and it genuinely matters. The 2 heavyweight forecast systems that meteorologists lean on most are the European model and the American model, essentially 2 extremely experienced navigators studying the same storm on the horizon. Most of the time they agree on the big picture, and right now they do agree that a block is coming and that cooler air is heading south. But they disagree meaningfully on how strong that block becomes and how far south the cold ultimately reaches. The American model leans toward a deeper, stronger block, one that would send colder air plunging much farther down the map. The European model sees the same underlying shift, but keeps it somewhat more restrained, cooler across the north, but not diving quite as dramatically toward the south. That gap between the 2 is the single biggest uncertainty in this entire forecast, and how that disagreement ultimately resolves decides whether the deep south gets any real relief at all in the coming weeks. There's a third piece worth adding, because it functions as the engine sitting underneath everything else described so far. Out in the Pacific Ocean, El Niño is strengthening, and it is strengthening quickly. Current outlooks from the Climate Prediction Center put the odds at greater than 90% that this becomes a genuinely strong event heading into fall and winter. That matters directly for what is happening overhead right now. El Niño warms a vast stretch of the tropical Pacific, and when that ocean warms, it shifts where thunderstorms fire off, near the equator, which in turn nudges the entire jet stream into a new configuration thousands of miles away. It stands as one of the clearest examples in all of atmospheric science of how the ocean and the sky remain wired together across enormous distances. The warming Pacific is helping tilt the entire deck toward exactly the kind of buckled, blocky jet stream pattern currently assembling overhead. This is not random noise. There's a driver behind it, and that driver is only getting stronger by the week. Walk through how this actually unfolds day by day, because timing is everything here. Right now, the first hints of change are already being felt in parts of the country. A cooler push of air has been sliding through, and it is real. But here's the catch that trips a lot of people up. This first cool shot is not the main event. It is a preview. Every single day, the heat tries to reinforce itself right behind it. A beautiful, crisp morning can give way to a temperature climbing right back up by afternoon. Across the northern tier, highs have been settling into the 70s, where readings had been baking in the 90s just days earlier, which represents a genuine break, though one that comes and goes rather than fully locking in. The pattern is still loading up, like a wave pulling back before it finally breaks. The real turn, the one this entire forecast is built around, arrives as the calendar pushes across the final days of August and into the opening days of September. That is when the block fully matures. That is when high pressure fully anchors up toward Alaska and up toward Greenland, and the jet stream carves its deepest trough down into the middle of the country. When that happens, a substantial cold front comes barreling south, and this one will not be a preview. This is the wave finally breaking. For the Midwest, the Great Lakes, the Ohio Valley, and the Northeast, the guidance points toward temperatures running 10 to 15 degrees below average, with the core of the coldest air potentially running 20 degrees below average. Let that number sit for a moment. 20 degrees below normal as summer transitions into fall is the kind of anomaly that makes people reach for a jacket they had already packed away for the season. Overnight lows in the coldest pockets could tumble into the 50s. And if the American model's deeper solution ultimately wins out, some spots could even flirt with the 40s. A genuine taste of early autumn arriving, while summer is technically still supposed to be holding on. Here is the twist buried inside this pattern that a lot of coverage is going to miss entirely. While all of that cool air floods into the north and east, the exact same pattern does something almost cruel to the southern part of the country. Building a giant block and forcing the jet stream to buckle does not simply create a cold trough on one side. On the flip side of that buckle, a ridge forms, a dome of heat, and this particular pattern shoves that heat dome directly over the west and the south central states. At the very moment folks in the upper Midwest are pulling sweatshirts back out of storage, folks across Texas, Oklahoma, the deep south, and the desert southwest are getting hammered by relentless, genuinely dangerous heat. This is not a small footnote buried at the bottom of the forecast. The Climate Prediction Center has issued a specific message warning about extreme heat and rapid onset drought building across the southern United States. That means the ground dries out quickly, the heat feeds on itself, and the entire situation becomes a genuine hazard rather than merely an inconvenience. Picture the map as a seesaw. Press down hard on one end, and the other end shoots up. That is precisely what is happening across the continent right now. The same atmospheric setup delivering blessed relief to the north is simultaneously locking a lid of heat over the south. In the hottest zones across the desert southwest, afternoon highs are still punching past 110, even 115 degrees. Across the south central states and the southeast, widespread readings over 100 remain on the table, with heat index values, the number describing what the air actually feels like on exposed skin once humidity is factored in, climbing well beyond that raw air temperature. The drought risk compounds the problem further because dry soil cannot cool itself the way moist ground does. Every additional hot day bakes the land a little harder, and that baked land then radiates even more heat back into the air the following day. It is a feedback loop, and once it fully gets going, it becomes genuinely difficult to break. It is worth explaining a bit more about why this heat and cold seesaw is not simply a coincidence of timing, but rather a fundamental feature of how blocking patterns work on a planet with a finite amount of atmosphere to redistribute. The jet stream, at its core, functions as a mechanism for transporting heat from the warm tropics toward the cold poles, constantly working to balance out the planet's uneven distribution of solar energy. When that transport gets interrupted by a block, the energy involved does not simply disappear. It has to go somewhere. Forcing cold Arctic air to plunge unusually far south on one side of a block necessarily means that warm air, displaced from its normal position, has to pile up somewhere else, typically on the opposite side of the same block, which is exactly the mechanism producing the heat ridge currently building over the west and south central states. This is not two separate weather stories happening to occur at the same time by chance. It is one single atmospheric event, with the cold plunge and the heat ridge representing two sides of the very same coin, mathematically linked to each other by the basic physics of how the atmosphere moves heat around the globe. That divide, cool and refreshing across the north, blistering and dangerous across the south, is the real story hiding inside this pattern. It amounts to a tale of two Americas separated by a single line on a weather map, and where any individual happens to live relative to that line decides essentially everything about the next 2 weeks of daily life. The farther the block pushes that cold front south, the more of the country escapes the heat entirely. If the American model proves correct and the block goes deep, that front could theoretically push all the way toward the Gulf Coast as the calendar turns into September, which would represent a genuine EA shock to the system for places that have not felt meaningfully below average air in what has felt like an eternity. If the European model proves correct, and the block stays more contained, the relief mostly stops short, and the south stays locked under that dome considerably longer. This is precisely why the difference between the two models keeps getting emphasized here. It is not a minor technicality. It is the whole ballgame for tens of millions of people trying to plan the next several weeks of their lives. Pull back from the big pattern for a moment and address the here and now, because a shifting pattern of this scale never arrives quietly. When cold air on the move starts colliding with warm, humid air that has been sitting in place for weeks, the atmosphere reacts, and that reaction takes the form of storms. Over the past couple of days, that clash has already produced rounds of rough weather, and the Storm Prediction Center is flagging more of it as the front continues, pushing through. The reassuring news, stated plainly and without unnecessary alarm, is that this is not shaping up to be a major tornado situation. The primary threat with these storms is damaging wind alongside large hail. And understanding why matters, because knowing the actual mechanism keeps people safer than simply hearing a generic warning. For the middle of this stretch, forecasters have painted what is officially called a slight risk of severe storms across the Central Plains, the lower Missouri Valley, and the upper Midwest. In plain language, that means scattered strong storms are likely, with some crossing the threshold into officially severe. The setup involves steep lapse rates, a technical way of saying the air cools off very quickly with height. And that kind of vertical profile functions like a ramp for rising air, letting thunderstorms build tall and strong in a hurry, layer in a boost of wind higher up, and the atmosphere as an overnight low-level jet strengthens. And the result is storms capable of organizing into clusters that produce damaging gusts as they race across the landscape. The Storm Prediction Center has been highlighting the potential for wind gusts strong enough to snap tree branches, knock down power lines, and cause the kind of scattered outages that leave entire neighborhoods without electricity for hours at a stretch. There's also a real hail threat, with some storms capable of producing stones large enough to dent vehicles and damage roofing in the most intense cells, potentially exceeding 2 inches in diameter. Geographically, the northern Rockies and the central high plains bear close watching as a shortwave, essentially a small ripple of energy moving through the upper atmosphere, dives southeast and touches off new storm development. The upper Midwest, across parts of Iowa, Wisconsin, and Michigan, sees storms firing ahead of the advancing front, potentially starting as isolated supercells, capable of producing large hail before collapsing into a line and shifting toward more of a straight-line wind threat by evening. The Central Plains and lower Missouri Valley are worth watching as storms cluster and grow upscale into a more organized system, carrying real damaging wind potential as it sweeps toward Missouri. Farther south, across Mississippi, Alabama, and into northern Florida, a very moist and unstable air mass supports additional storm activity, though wind shear there runs weaker, meaning those tend to be more of the pulse and collapse variety that can still pack a sudden, sharp punch through downburst winds. Looking a day further ahead, the severe threat shifts and reorganizes around parts of the Ozark Plateau into the mid-south, with 1 or 2 clusters capable of producing swaths of damaging wind. There is even mention of central and southeastern Arizona getting drawn into the picture as monsoon moisture interacts with the local terrain. The tornado risk across these days remains low, generally sitting in the 2% range, which forecasters classify as a marginal, isolated concern rather than a widespread danger. If a brief, isolated spin-up does occur, it would most likely be quick and short-lived rather than the sustained, long-track systems associated with peak spring severe weather season. Heading further into the outlook, the focus of activity nudges into the northern plains, from Minnesota into Nebraska and northern Kansas, with large hail as the headline threat, driven by that same combination of strong shear, steep lapse rates, and just enough available moisture. A separate, smaller threat for locally damaging gusts sets up from eastern Virginia into the Carolinas as a wave crosses the Appalachians. It also helps to understand why wind and hail, rather than tornadoes, dominate the threat with this particular type of severe weather setup. Tornado formation generally requires a very specific combination of ingredients: strong instability paired with strong low-level wind shear that turns with height in just the right way, creating the kind of rotating updraft that can eventually tighten into a tornado. The storms expected with this transition carry plenty of instability and plenty of shear aloft, but the specific low-level wind profile needed to generate widespread rotating supercells capable of producing significant tornadoes is largely absent from this particular setup. What remains instead is a combination of steep lapse rates and strong mid-level winds that favor storms capable of producing extremely strong straight-line winds and large hail as they organize into clusters or lines, a distinct and still genuinely dangerous threat, but a different one than the tornado outbreaks more commonly associated with the peak of spring severe weather season. A practical note is worth including here, because a forecast is only genuinely useful if it changes what people actually do in response. When storms of this character move through an area, the single most important preparation is having a reliable way to receive warnings even while asleep. A weather radio or phone-based alerts can wake someone the moment a warning is issued for their exact location. Damaging winds and large hail do not require an accompanying tornado to be genuinely dangerous. A 70-mile-per-hour gust can bring a mature tree down onto a house just as easily as it can knock out power across an entire town for an extended period. Taking these threats seriously, bringing loose outdoor items inside, parking vehicles, undercover where possible, and knowing the sturdiest interior room of a home in advance costs essentially nothing in preparation and can meaningfully reduce risk when a warning arrives. Tie these individual storms back to the larger pattern because they are not a separate story unfolding on the side. They are the audible friction of the pattern changing in real time. Every one of these fronts marks a boundary between the old air mass and the new one, between the summer air fighting to hold its ground and the cooler regime working to take over. As the block matures over the coming days, an upper ridge is forecast to expand from the Four Corners region into the southern plains, while the flow aloft over the northern plains bends and shifts east across the Midwest and into the Northeast. That is the visible signature of the entire pattern, coming together. The storms during this transitional stretch represent the friction of that changeover. Once the block fully locks in and the significant cool anomaly settles down over the northern and eastern states as the calendar turns toward September, the atmosphere calms considerably in those regions, because the sharp temperature contrast that fuels storm activity migrates south along with the front itself. A brief word on the tropics is worth including as well, since chatter has circulated about a system out in the Atlantic, and an honest grounded read matters more here than a dramatic one. There's a possibility of a tropical wave attempting to develop out in the Atlantic, but the odds of it becoming something significant enough to threaten land currently remain low. The fascinating part is that the very same pattern already described plays a direct role in that outcome. Recall the strengthening El Niño mentioned earlier. One of the things a strong El Niño reliably does is crank up wind shear across the Atlantic basin. Wind shear, meaning winds, blowing at different speeds and directions at different heights, proves absolutely brutal for a young tropical system trying to organize. It rips a developing storm apart before it can properly form, tilting and shredding the tall thunderstorms that any hurricane fundamentally needs in order to survive and strengthen. On top of that, if the block sends a cold front pushing far enough out over the Atlantic, it can inject dry, stable air along with additional shear directly into the path of any wave attempting to spin up, effectively pushing it away and keeping it weak. So, while the tropics are never something to fully ignore during hurricane season, the atmospheric deck is currently stacked against major development, and that outcome traces directly back to the same forces reshaping the forecast across the rest of the country. Get concrete about the actual temperatures worth expecting, since that is ultimately what matters most on a day-to-day basis. In the immediate term, highs across the central and northern parts of the country settle into the 70s and 80s, a welcome step down for many. Push into the central and southern states, though, and readings over 100 remain firmly in play, with the southeast running in the high 90s to around 100 and the desert southwest still cooking past 110 to 115. Remember that those figures represent raw air temperature. The heat index, the feels-like number, runs noticeably higher once humidity gets factored in, which is exactly why the Climate Prediction Center continues warning about extreme heat as a genuine hazard rather than simply an uncomfortable inconvenience. As the days tick by, each cold front that swings through knocks the northern temperatures down a notch, but the underlying heat keeps trying to rebuild right behind it. The result becomes something of a rhythm. cool, then warm, until the larger block finally slams the door shut for good. That decisive moment, the deepest cool shot of the sequence, is the actual payoff of this entire forecast, and current guidance lands it as the calendar crosses from the final days of August into the opening stretch of September. That is when the coolest air arrives considerably deeper and colder than the earlier appetizer shots with the Midwest, Great Lakes, and Northeast, potentially running 10 to 20 degrees below average, overnight lows sliding into the 50s, and in the more aggressive scenarios, into the 40s in a few isolated spots. When forecasters compare the shorter range models against longer range climate guidance, there is general agreement that cooler air is genuinely coming, though the longer range guidance runs a touch less aggressive about exactly how deep that cold ultimately dives. That represents the same American versus European tension resurfacing in a slightly different form. The overall trend, the direction everything is leaning, favors the colder outcome for the northern tier, and possibly a push of that cooler air farther south than has been seen in quite some time, assuming the stronger version of the block ultimately verifies. So, who ends up where once the dust settles? A large share of the northern and central country lands comfortably in the 50s and 60s for overnight lows, with pleasant daytime highs that finally feel like the genuine turn of the season. The zone that had been stuck in the 90s drops into the 70s. The zone that had been baking in the triple digits may ease into the 80s, but the far south and the desert southwest, sitting directly underneath that persistent ridge, stay hot, and if any relief reaches them at all, it arrives late and remains fairly modest. Then, as the calendar moves further into September, current guidance hints that the cold front could push even deeper still, which would extend and expand the relief considerably. That represents the more optimistic branch of the forecast, and it is worth watching closely in the days ahead, because if it holds, it would mean a genuine, lasting break in the heat for a much larger share of the country than the more conservative scenario allows, extending relief into regions that have gone the better part of the summer without a meaningful stretch of comfortable weather. Step back now and assemble all of this into one coherent picture, because the whole point is understanding this pattern as a working system rather than a headline. A rare double block is forming, one dome of high pressure anchoring near Alaska, and another near Greenland, forced into place partly by a rapidly strengthening El Niño out in the Pacific. That double block buckles the jet stream, carving a deep trough down the middle of the country that floods the north and east with unusually cool air for this point in the calendar, while simultaneously building a heat ridge that traps dangerous, drought-feeding heat over the south and the desert southwest. The clash between incoming cool air and lingering summer warmth fires off rounds of storms, mostly wind and hail driven rather than tornadic, as the broader pattern rearranges itself overhead. And the single biggest question left hanging is how far south that cold front ultimately pushes, a question the American and European models are actively arguing over right now, with the deeper, more dramatic solution favored by the American model and the more restrained version held by the European model. Confidence that meaningful relief is genuinely coming rests on the fact that the driving signals, the negative North Atlantic Oscillation, the negative East Pacific Oscillation, and the strengthening El Niño, are all pointing in the same direction at the same time. That kind of alignment across multiple independent signals is what gives a forecast real structural backbone, rather than relying on a single isolated data point. It helps to understand why forecasters place so much weight on these particular oscillation indices, rather than simply watching the raw temperature maps day to day. Each of these indices functions as a kind of early warning gauge for pressure patterns that typically take days to weeks to fully translate into the weather actually felt at ground level. The North Atlantic Oscillation, for instance, has been studied for well over a century, with records extending back into the 19th century in some data sets, precisely because sailors and early meteorologists noticed that pressure differences across the North Atlantic reliably predicted shifts in European and North American weather, well before satellite technology existed to confirm the connection directly. A negative phase reliably correlates with blocking near Greenland, and cold outbreaks reaching into eastern North America and Western Europe, a relationship robust enough that it remains one of the most trusted indices in the entire forecasting toolkit today. The East Pacific Oscillation performs a similar function for the western side of the continent, tracking pressure patterns over the northeastern Pacific that reliably foreshadow ridging or troughing over Alaska and the Pacific Northwest days before that ridge or trough actually forms, when both indices swing in a mutually reinforcing direction simultaneously, as they are doing right now. The confidence in the resulting forecast rises considerably because two independent measurement systems, each with a long track record of reliability, are effectively confirming the same underlying signal from two different geographic vantage points at once. What remains genuinely uncertain is the exact temperature in any specific backyard on any specific day several days out, because the depth of the block is still being sorted out, and this remains weather, meaning it will wobble and shift somewhat between now and when it fully arrives. What can be said with real confidence is that every subsequent model run, every update to those key underlying signals, continues pointing toward the same broad outcome, even as the finer details of exactly how far the cold plunges or how soon the block eventually backs off continue to evolve. Anyone who has followed this description now understands a pattern that is about to define the next 2 weeks of weather for tens of millions of people, not merely as a headline glimpsed in passing, but as an actual working machine, with gears turning from the Pacific Ocean to the top of Greenland and finally down to ground level outside an ordinary front door. The heat that has felt like it might never end is finally meeting a genuine structural match in the atmosphere above it, and the door to autumn is cracking open earlier than much of the country expected just a week ago. Whether that door swings open wide enough to reach the deep south before the calendar turns fully into fall remains the open question worth watching closely over the days immediately ahead. And it is a question that will be answered not by any single forecast, but by how the block itself continues to evolve, run by run, over the coming week.